Hello guys, gals, and everything in between. You might remember from my last video, we talked about transformations of absolute value functions. If you have not already, go ahead and pause the video here and write down those transformations. They will be very important for these examples that we're going to look at together. We're going to take a look at how to find the vertex today. When you look for the vertex, you want to think opposite h exactly k. Remember that absolute value functions look like the letter V when you graph them. The two lines meet at a point. That point is called the vertex. Let's go ahead and take a look at this first example. Y equals 1/2 times the absolute value of x. The first thing that I want to do is write down my transformations. When I look at this number 1/2, that's in front of those absolute value symbols, I assume that this is my A in the y equals A times the absolute value of x minus h plus k. That A is in charge of a stretch, a compression, or a reflection. Because we have 1/2, which is in between 0 and 1, we can say that this compresses by a factor of 1/2. I like to make a table of values so that I can organize my points. The first point that I want to find is the vertex. I'm looking for the opposite of h and exactly k, but in here I don't have an h and k, so my vertex is at 0, 0. I'm going to use my graphing calculator here to figure out the rest of those points without having to do a lot of math by hand. So the first thing that I'm going to do is hit y equals. Then I'll type in 1/2 or 1 divided by 2. If I hit second math, or sometimes just math, depending on what calculator you have, I'm going to look for this button called ABS, ABS, for absolute value. And in there, I'm just going to put an x. The x that you want to use is the variable x and not the alpha x. Be careful there. When I hit enter, you'll notice that this looks exactly like my equation that I wrote on my paper. Now I'm going to go ahead and look at my graph. You'll notice that on my calculator, graph is in yellow, so I have to hit the yellow button and then graph. Yours might look different. Notice how it looks compressed. It looks like it got smushed. I can also hit table, and I can copy those table values onto my t-table on my paper. I also don't really like graphing decimals, so I'm going to skip the decimals that I see on my t-table on my graphing calculator, and I'm only going to write points that are whole numbers. That way my graph on my paper will look a little bit nicer. You can find these values by hand by choosing x values to plug into the equation to find your y values. Now that I have my table of values, I can go ahead and put this on a graph. Normally I would use graph paper for these graphs, but I didn't have any, so here we are. I'm plotting these points, as you can see, from left to right, -6,3, -4,2, and so on. We can see our vertex really well here, and we can notice the compression. When we take a look at the domain, we want to read our graph from left to right. On the left, I see that that graph is pointing to -infinity, and as I go to the right, I can see that that graph is pointing to +infinity. Remember that our domain for absolute value functions is always the same. For our range, we read our graph from bottom to top. Our first y value is at 0, and our last y value points to +infinity. Our next example has a negative in front. That negative is a reflection over x. So my first transformation is reflect over x. The next thing that I'm going to look at is that +2, which is an h value. When our h is positive, it shifts us to the left however many units. So here I'm going to write shift left by 2, or I could write shift left 2 units. Remember that the first value that I want to find is my vertex. I want you to go ahead and use opposite h exactly k to find your vertex, and then either use your graphing calculator or choose x values to plug into your equation to find your y values. Pause the video here, look for that t-table, and come back when you're finished. I used my graphing calculator to find these points. So I hit y equals, I hit the negative symbol. I also found abs in the math button. Abs, remember, stands for absolute value. I then typed in x plus 2 into those parentheses and closed the parentheses. Remember that that x that you're using is the variable and not the alpha. I then clicked graph to take a look at what this looked like. I can see that this is a reflection over x, so that's kind of cool. I can also see that that vertex moved to the left. And then I clicked on table and I copied that table of values onto my paper. Again, you could do this by hand. It's going to take you a little bit longer, but you can just choose x values on the left and on the right side of your vertex, plug those in individually, and calculate the y values by hand. Now that we have that table of values, I can go ahead and plot those points on my coordinate plane, and I can connect the dots to make the shape of my absolute value graph. I can then analyze my graph from left to right and from bottom to top to write my domain and range. My domain is still going to be from negative infinity to positive infinity as I read the graph from left to right. The piece that's going to change here is the range. So pay attention. Remember, read your graph from bottom to top. The first y value we get to is negative infinity here. Those arrows are pointing down forever and ever and ever. And the last y value we get to is 0. I now want you to put all this information together and try this on your own. Find the transformations, the t-table, plot those points on a graph, and describe the domain and range. Pause the video here and come back when you're finished. To find those transformations, you're looking at x plus 6. That plus 6 shifts us to the left 6. And then that minus 1 at the end is a k value, which shifts us down 1. That also helps us find our vertex. Opposite of h is negative 6, and exactly k is negative 1. To find my t-table, I plugged that into my calculator. Again, you can find those points by hand by looking for x values on the left and on the right of that vertex. After I plot those points, I can go ahead and find the domain and range. Here, the domain is still negative infinity to positive infinity, and my range I read from bottom to top. So that first y value I get to is negative 1. The last y value I get to points at positive infinity. This next example will be the last one that we look at today. Remember that you want to describe your transformations by identifying the a, h, and k. Here, my a is 2, which stretches my graph by a factor of 2. My h here is negative 1, which shifts my graph to the right 1 unit. And my k value is positive 4, which shifts my graph up 4 units. Remember to write your vertex first. So opposite of h here is going to give me positive 1. Exactly k is going to give me positive 4. Now I can find x values on the left and on the right of that vertex. When I plug that into my calculator, after I hit y equals, I'm going to type the number 2. I'm going to look for abs in my math button for absolute value. I'll type in x minus 1 and close the parentheses. Then I will type plus 4 and hit enter. Now I can click on graph so I can see what my graph looks like. Notice that it's a little farther up, it's a little farther to the right, and it's also stretched a little bit, which is kind of hard to see, but we'll see it once we plot this on the graph. I'm going to look at my table to find those values to write on my t-table on my paper, and I'm just going to copy directly from my graphing calculator. Again, you can find these points by hand by plugging in x values on the left side of the vertex and on the right side of the vertex. You can plug those in individually, one at a time, into the equation to find your y values. It will take a little bit more time. That graphing calculator, I'm telling you, it's going to save your life and save you a lot of time and a lot of possible mistakes. Now that I have my t-table completed, I can plot these points on my coordinate plane. You can see that my y values are much more stretched apart. That's because of that stretch by 2. Once you plot all of these points and you connect the dots, you can read your graph from left to right and from bottom to top to write your domain and your range. Our domain, again, is negative infinity to positive infinity. That graph points to the left forever and to the right forever, to infinity and beyond. Our range, however, starts from the bottom and goes to the top. Our first y value that we get to is +4, and the last y value that we get to is +infinity. Thanks for coming. Hope that these examples helped. Have a great day. We'll see you next time.